Okay, this is chemistry, continuing with our gases unit. So this lesson will focus on rearranging the ideal gas law to solve for density. So if you want to solve for density using the ideal gas law, what would that equation look like? Well, let's take a look at what we already know. We already know the equation for density is D equals M over V, mass over volume. We already know the ideal gas law is PV equals nRT. And from my last lesson, we now know that rearranging the ideal gas law can help us solve for molar mass, which is the capital M, capital M. All right, now if you take a look at this equation that solves for molar mass, what is molar mass equal to? Do you see this M over V? Do you recognize that? That M over V is density. So we can rearrange this so that M over V is by itself. So that's what I'd like to show you now, is how we can rearrange this equation that solves for molar mass to have it solve for density. So the V needs to stay, but that P needs to be removed from the right-hand side. So in order to do that, you need to multiply each side by P. So now the P is gone on the right-hand side, and now we have MM molar mass times P, and I left alone mass times RT over volume. But this is not quite what I'm looking for yet. I want just M over V. So in order to get M divided by V by itself, I need to get rid of RT. So to get rid of RT, I will need to divide on each side. So it looks like this. So molar mass, MM times P over RT is now equal to M over V. And what is M over V? That is density. So this is how you rearrange to solve for density. So density equals molar mass times pressure over the gas constant times temperature. So now let's practice an example problem with density and see how to solve this. Okay, so this question is asking, what is the density of NH3 at 800 torr and 25 degrees Celsius? So it looks like you have some information, but not quite enough to solve the problem. Looks like you're missing something. So 800 torr is P for pressure, 25 degrees Celsius is our T for temperature. The R we can look up, but what you're missing is molar mass. You do have a formula. You do have NH3. So if you know the formula, you should be able to calculate molar mass on your own. This is a skill we've learned. So in order to do that, you would need the periodic table. Let me get that back up for you. Okay, so our formula is what? NH3, right? So here's your N, and here's your H. So what piece of this do you need to use? Well, what have we been talking about? You need to use this decimal number, right? That is the gram per mole for nitrogen, or the gram per mole for hydrogen. So nitrogen is going to be 14.01, hydrogen is going to be 1.01. So here's what I need to do. There's my formula, NH3. I need to get the molar mass. So 14.01, I just wrote it because there's one N. Hydrogen, you have 3 of them. So you take 1.01, that's the mass of hydrogen, times it by 3, and you get 3.03. Together, this becomes 14.04 gram per mole. That is the molar mass of NH3. And that should look familiar. We use this a lot in our stoichiometry unit. So I hope that looks familiar. Now you have all of the information to solve. So I'm going to put these values into the formula and also color code it to help you solve easily. So here we go. So density equals pressure, molar mass, over gas constant times temperature. So now just use what you know. P for pressure, 800 torr from the problem, and I just colored it green. Molar mass, you just solved for this, 17.04 gram per mole. R, I chose 62.4 liter times torr over mole K because the 62.4 is torr, and it matched the pressure for torr. 298 Kelvin. Where did the 298 come from? I have 25 degrees Celsius. You cannot solve gas laws in Celsius. You have to convert to Kelvin by adding 273. So now before I do anything else, I'm going to get rid of some of my units here. So what I did is I just got rid of my units on the bottom. The Kelvin and the Kelvin are going to cancel. So right now I just eliminated those two because they were on the denominator. So what I'd like to do next is multiply the top and multiply the bottom separately. And then you're going to see me also show some cancellations of our units. All right, so if I multiply 800 times 17.04, I get 13,632. And it was torr gram per mole. Bottom, 62.4 times 298 gets me 18,595.2 liter torr over mole. So now, like units, we'll cancel torr and torr, mole and mole. So I should be left with my units for density. Density is a mass per volume, so it should be gram per liter, and it is. So when I divide, I get 0.73309, and I just chose to use significant figures there, but you don't have to. 2 decimal places is fine. G for grams over L for liter. So that is how you solve for density.